What I'd like to do now is get a little more advanced with what we're doing with the canvas. We're still going to have this animation loop going on, but we aren't going to need it for a little while. So I'll tell you what I'm going to do. I'm going to just take this whole example here, and I want to make a new one. I'm going to paste this in. I'm going to just call this example6.html. And let's clear out all of this stuff except for the very beginning stuff where we get the canvas. So I want to do that just so that we're kind of starting from scratch here. Now I want to do a couple different things. The first thing I want to do is show you how you can use gradients in Canvas. This isn't something that's all that important, but it's just gives us a little more exposure to this, and it's, again, one of the fun tools that we can do with this. So I'm going to be drawing a background gradient for our canvas here. So I'm going to create a function for that. Function draw background gradient. Inside this, we're going to do something fairly straightforward. First we have to do is create the gradient itself. And we do that using the canvas context and saying create, in our case, a linear gradient. And a linear gradient is just one that follows a straight line, not necessarily left to right. It can be diagonal, it can be top to bottom, whatever you want. Really, it's just in contrast to a radial gradient. A radial gradient starts at the center and moves out in a circular way. We're not going to do that. This is just a straight linear gradient. Now, the parameters to this are first the starting point, which we're going to say is 0, 0, and that's where the gradient line starts. And then you need to give it the ending point. And this for us is going to be 0 still, so it doesn't change in the x. And then canvas.height. And that means that I want the gradient to basically be vertical, because I'm giving it a vertical line from 0, 0 to 0 height. And I'm saying make it the full height of the canvas as well. Now that creates, C-R-E, creates the linear gradient, I need to spell it right, and returns it as a variable, so we need to store it. So let's call this lingrad. That is our linear gradient. Now that just describes the direction of it. Gradients themselves are just slow changes from one color to another. So we have to tell it what colors it should have where. You do this by saying lingrad.addColorStop, and basically says at this point in the gradient I want you to have this color. The first stop we'll add should be at 0. And the color we're going to want right there is white. And that's FF, FF, FF. This is a web color. Hopefully you're familiar with these. The first two are the color, or the amount of red. The second two are the amount of green, and the last one is the amount of blue. And FF is hexadecimal. Basically, it's the largest hexadecimal value you could give to this. So any 2 hexadecimal digits represent 8 bits of information. FF is equivalent to 255 in decimal values, and 0, 0 would be 0. So this is how we define colors for the web. Now, of course, we could also just say white. That works, but I want to start getting you used to looking at these hexadecimal values. And you can read all about these on the W3 schools if you'd like to get a little more info. But I'm hoping that you've probably seen them before. Now let's go ahead and add another color stop, because 1 isn't enough. You always have to have at least 2. So lingrad.addColorStop, and we're going to just go 2 colors, 1 at each end. And at the other end, I have this special color that I've figured out already. So it's C8 on red, which I believe is 250, and then C8 on green, and FF on blue. So this is actually a little sort of purplish color, I believe, pinkish purplish kind of color. And so it's going to go from white to that. That's going to be our gradient. Now I want to just take this and use it to fill the entire screen. So kind of like before when I erased the screen using clearRect, I'm going to say now context.fillRect. And I'm going to say 0, 0, canvas.width, canvas.height. So I'm going to draw a rectangle over the entire screen. And the only thing I need to do is make sure that it's set up to use that gradient for filling before I do the fillRect call. And that's actually really easy. We just say context.fillStyle equals lingrad. As long as you set that to the gradient, it will know what to do. So the effect of this now is that it is going to draw that background gradient. Now it's not going to do anything yet. Why is that? It's because I haven't called the function. So let's do that. Draw background gradient. And then I'll put a little comment on my function. Draw a vertical gradient over the entire canvas is what it does. So we set up the gradient, set it as the style, and then fill a rectangle. Let's go back here, say bye-bye to our little worm, and see what we get. Oh. Ah, silly boy. We changed it to example 6, didn't we? Let's go to example 6. There we go. So there you go. You can see it starts as white at the top, and then it goes to this nice lavender kind of color at the bottom. So that's our linear gradient here. So this is kind of step 1. The nice thing is, because this fills the whole screen, we don't have to clear the frame anymore. Every time we draw this gradient, it actually has the effect of clearing the previous frame. So when we use this as an animation, we'll use this in place of that clear rect call, because it has the same effect that clear rect did. Now, let's draw. I'm gonna create a little sort of bunch of triangles that emanate out from the center of the screen is what I want to do. So we'll call this draw triangle wedges. These are going to be little pie wedges that originate out from the center of the screen. Little triangles is what they are, and give that sort of tunnel kind of effect as we're looking into the screen. Now, how do we achieve this? The idea itself is pretty straightforward. Again, I'm going to use that same purplish color or lavender-like color I had before. So I'm going to say context dot fill style equals, and this time I want just that final color that we had on the gradient. So it's going to look like that. Now I want to draw a bunch of these triangles. So I'm going to say for, because we need a for loop to draw a bunch of them, I equals 0, and we'll jump around the circle and draw 10 of these. So we'll say I is less than 10, because we start at 0 and go strictly less than 10. That means we'll be doing 10 things. I plus plus. And so now we have a loop that's going to count from 0 to 9, basically, and allow us to do things. Now, what I want to draw here is a triangle. Hopefully you've read the book. You saw that drawing triangles is a little bit trickier. Triangles are not as easy to draw because there isn't a draw triangle. There isn't like fill try or some sort of function like that. Instead, we have to do what's called a filled path. A filled path is really just a way to draw any polygon, i.e. a shape with any number of sizes. And so we're going to do it real simple. We're going to just do a triangle. To do this, first we have to begin our path, B-E-G-I-N, path. Then we need to execute some things. First, we want to set the starting point, and so you usually do context.move to. And this basically says pick up the pencil and put it at a new location. So you don't leave the pencil down. You aren't going to draw a line. You're going to just pick up the pencil and move it to a new location. In our case, we want that to be the center of the screen, 0, 0. Now, we want to draw a line. So we're going to say context.line to. And this is going to go from 0, 0. And we want to go from 0, 0 along the circle out to a certain point. What we're going to use here is actually something called polar coordinates. And this is a system that's just defined as a radius times a particular angle in order to figure out where you are around or a radius and a particular angle. So the angle itself is going to be defined as basically 1/10 the size of the angle of a circle. So 36 degrees, and whatever that is in radians. I don't know it off the top of my head, but we can compute that. So I'm going to need that value, and I only need to compute it once. So I'm going to compute it up here. Var wedge size, and this is going to equal math.pi, and specifically 2 pi, because that's the full circle, right? 2 times math.pi divided by 10. This is the size, the angles of one single wedge, because I want to divide the whole circle into 10 wedges. So I take the radians for a full circle and I divide by 10. And that's the size of a single wedge. So here, I want to draw a line from my current location, which is 0, 0, out to a location that is on the circle, but at this angle out in the wedge. Now, initially, that angle is 0. So it's going to be, but it's going to change every time we go through this, because we're going to be moving around the circle, just like clock hands. And technically, they're going to move around counterclockwise, but that doesn't really matter. We're not going to see it. So here, we'll say I times wedge size. And actually, I'm going to even just make this a variable. Why not? As we come into this, we're going to say var angle equals I times wedge size. Now, usually what we do is we say that the x value that we want to draw at is going to be the cosine of that that particular angle. And why? Well, because cosine of an angle equals 1. And when we're starting at the beginning part of a circle, we like to start way over at the right at 1, and then we go up to y equals 1, and then back to -1. So the x value behaves like cosine. In the end, though, it really doesn't matter which one you use, as long as you use both. So I'm going to say take the cosine of the angle, and then I need this triangle to be a certain width. Initially here, I'm going to multiply it. If we were to just say this, that would be a circle with a radius of 1. I want a bigger radius than that, though. So let's say canvas.width. But let's not actually, let's say width divided by 2, because we want to be able to see it initially. So 1/2 the width of the screen. We also need a y value. For that, we use the other function, sine of the angle, and again, times canvas.width divided by 2. And so that takes us out. We then need to move, we then need to move forward a little bit. And so for that, we're going to compute another angle, angle 2, which is going to equal I plus 1/2, 0.5, times wedge size. So this is 1/2 of a wedge along. So this would be 1/2 the width of a wedge. That's what we're making here. Let's put these on 2 different lines. And so I'll use that one down here. So one side of the triangle is going to go straight out where the wedge starts. The other side is going to move halfway towards the next wedge, and that's how we'll make a little triangle. So our triangle goes from 0, 0 out to cosine sine, and then halfway to the next cosine sine. Which is the outside of the circle. The cosine and sine are always the outside of the circle. 0, 0 is the center of the circle. If all of this seems a little bit complicated, don't worry. This is, well, technically this is a math class, but we're not really going to quiz you on this kind of stuff. I just explain it in the hopes that you can follow it a little bit and start to learn how to use things like cosine and sine to define shapes. But it's just sort of ancillary information. The most important thing here is now that we're done, we need to say context.fill. And so then it will take that shape we just defined between begin path and fill, and it will actually fill it in as a triangle. In order to make that clear, I like to actually indent those out a little bit, because everything between begin path and fill is what actually becomes the triangle. You don't have to do that. It's kind of arguable whether people like that or not, but I do like it, so I'm going to do it. So there we go. So what happens here? It draws 1/2 a wedge with this color. Then it comes around, it's going to move forward an entire wedge. So half of the wedge will remain blank. And then it will draw another half of wedge. And it'll keep going until it draws 10 of those around the circle. Let's go see what this looks like. Now we have to remember here, we're drawing the background gradient. We need to now draw triangle wedges, so that we're calling both of these. And let's see what we get. Nothing. All right, what did I do wrong? Let's inspect element. I've got an error. What is my error? Context.line2 is not a function. All right, well, let's think about that. It says, ctx.line2 is not defined. We need to figure out why. And I actually know why, but I want you guys to think about it. Do you see anything here that maybe looks like it's wrong? Let's go see where this is in the code. And of course, it's these two right here. The general rule of thumb is that functions should always start with a lowercase letter, as well as variable names should always start with a lowercase letter. And you can see here I'm starting it with a capital one. That is a mistake. It should be a lowercase l, line 2. All right, let's try this again. Hey, there they are, sort of. Something's a little funky here. You can see the triangles, and they are kind of coming out in the form of a circle, but they're up in the corner instead of in the center. And that was definitely not what I wanted. I wanted them to be coming out from the center like a tunnel. I actually did this on purpose because I wanted you guys to sort of run into this. And remember that whenever you're drawing inside a canvas, you're always oriented to the top left corner, not to the center. When we do things in math, we often think of the center as being 0, 0. Now you can just adjust your thinking and completely change it. That's fine. But there's also a really easy way to just force everything to happen at the center. We can put what's called a translation on the entire system. Before we draw these things, we could say context.translate. And we're going to translate out to the center. So we're going to say we'd want to basically go to the center of the canvas. And in order to make that work really well, I'm going to pre-compute it. I'm going to say var center x, and what's that equal to? Well, it's the width of the canvas divided by 2. And same thing here, center y, only this is going to be the height of the canvas divided by 2. And that'll get us the center. Then we can do this translate call. Now what does translate mean? Translate is basically shifting your current origin a certain amount in the x and y dimension, so left and right and then top to bottom. First we give it the left to right, center x, and then we give it the top to bottom, center y. Now here's a rule of thumb that's important. This would actually work if we were to run it right now, but this would be breaking one important rule. And that is, if you ever change the context, like we're doing here, you should always make sure that you change it back when you're done. The reason is, if someone else were to be using that same context, they would not expect this. They wouldn't expect the center to have been translated to 0, 0, and so their code wouldn't work. If you're working with other people and you're all writing separate functions that are taking advantage of the same canvas context, they have to be able to trust the context. In fact, this is a fundamental thing that comes from computer graphics, and all state machines and contexts have a way to save their current state before you change it. Sometimes it's called push, but in this case it's literally called save. We say context.save. Then when we're all done, where we needed the context to be like that, we're going to want it actually for both of these. It'll still work fine for the gradient. We don't have to worry about that. Then we say context.restore, and that undoes any changes that we made between here and there. And actually, I take it back. We only want this for our triangle wedges, right? So we should put it down here. So we move the center for our triangle wedges, but not for the background gradient. Now let's see what we get. There we go. That's what I wanted. So here we have these triangles kind of emanating out from the center. Now I don't want to see the triangles. I'm going to fix that eventually. Right now I can see them because I left it small enough, so just you'd understand how this works. In fact, let's go a step further here so you can see exactly what we're getting. Let's do canvas width divided by 4. And really we should be doing canvas width, canvas height. When we're on the y, it should be height, and when we're on the x, it should be width. And there we go. You can see it's even a little elliptical because this is not a square. That's what we created. Let's go ahead and make this exactly what we want it to be. I want this to go all the way out to width and height, which is a little bit of overkill, but I want to make certain that we don't see the end of those triangles. I want to just be looking straight down like we're looking down a tunnel. And there we go. That's the effect I'm going for. So hopefully this is what you're getting now. Now we're ready to animate. We haven't been doing any of that yet, but we do want to eventually. Right here is where I'm doing all my drawing. This is where I call draw background gradient, draw triangle wedges, where I set up my context so that it will do what it's supposed to by translating before I do it, where I save and restore my context. This is basically where the frame gets drawn. Let's go ahead and make a function for this. So just like before, we're going to call it draw frame. And then I'm going to take all these and move them right into that. So the first thing we do, we save the context, then we draw the background gradient, which also clears the whole screen. We're going to recenter the scene and then draw our triangle wedges, and then we'll restore the context back to what it was. Then just like before, we want to turn this into an animation. So we'll say request animation frame, draw frame. Again, we only pass it the function name. We don't call it, so no parentheses on this. We give it the function name that we want called to draw the animation. And now remember, that will only do it once. We then go inside draw frame and we set it up to call itself at the end so that it will redraw the whole thing again. Now this isn't actually going to move at all yet. We need to do something here. Let's give ourselves a current angle, and we'll set it equal to 0. What I'd like to do is to rotate those triangles so that they're spinning a little bit. And we'll say that they'll always be offset by this angle. I'm just declaring this up at the global level so it's accessible everywhere. As the animation frame changes, let's keep the angle moving forward a little bit. Think of it as being in radians, so we're going to be small here, just a little step forward. This is very similar to what we were doing when we were animating that worm before. Now, down here, when I get to draw triangle wedges, before I draw any of this, I want to rotate the whole scene. I could try and put an offset or rotation into our angles here, but that would actually be a little bit complicated. Rather than doing that, let me add a rotation right here. I can say ctx.rotate by angle. And then I want to make sure when I'm done with that, I still restore back to what it was. So just before I draw the triangle wedges, I'm going to rotate by that angle. And that angle is going to increase over time. So all the motion now is actually over here in draw frame. It's kind of nice. Let's come back over here and see if that works. There it goes. That's even a little bit fast, isn't it? But that's the effect we were going for. Let's try slowing this down a little more even. Refresh this. There we go. Super Tunnel of Doom. Well, Lavender Tunnel of Doom. Alright, so we've got our little animation going now. Another thing I want to do, I do want to go ahead and make my canvas square here. So I'm going to come back up to the tag where we defined it and change its dimensions so that it is in fact square. There we go. Alright, we're getting close to the final goal that I had here. We've got a little bit of animation, we've got this funky thing with the sort of faded purple in the background, which is just me trying to be a little bit fancier with our design to make something that's pretty. Let's go ahead and give this a sort of finishing touch here. The next thing I would like to do is draw a shape right in the middle of all of this. So we've got our background gradient, we've got repeating triangle wedges. The last thing I'd like to draw in the middle of this is a heart shape. And we're going to draw this using something called a Bezier curve. And that might sound fancy, and in fact there is actually some really good math behind this, but for the most part Bezier curves are pretty simple. They're something you've seen before almost certainly. Anytime you've had an opportunity to create a curve inside of Photoshop or inside of Illustrator, it probably gave you a couple little handles you could pull on to define what that curve looked like. That was a Bezier curve, and as you were adjusting those handles, you were adjusting the control points of the Bezier curve. Let's just call this draw heart. And for this, I've actually gone and already looked up the different control points we need to draw a heart shape. So I'm going to be cheating here a little bit. I've created a little snippet for this. So it's called B heart. Ooh, come on. Let's pull that in. And there it is. And to give credit where credit is due, I have the place where I got these numbers from as a website here that you could go visit. It's going to keep cutting it onto multiple lines because it's a very long website link, but I want it to be there so you guys can go check it out if you want to. So here's what this looks like. Just like up here where we did begin path and then went to a certain origin and then drew a couple straight lines to other points. This path is going to draw curves between points. So it still starts at 0, 0, but then it's going to draw a curve using these control points for the curve. Now, how you figure out these control points, honestly, you usually use a tool like Illustrator and push and pull on those until you get just the right shape that you want. And so we're going to draw 4 Bezier segments, and these 4 segments are actually going to be first, I think it's the left side of the curve and then the right side of the curve of the heart. Sorry, left side of the heart, right side of the heart. That's what these are. When it comes time, we're actually going to do 2 things to it. We are going to quote-unquote stroke it, which means draw an outline of it, and we're going to fill it. And we're going to give it 2 different colors so that it has a nice style to it. I've already sort of predetermined those colors. So we say context dot, let me look at my notes here. Context dot stroke style is going to be, in our case, FF0000. That's pure red. And then context dot fill style is going to equal FF6400. And that ends up being a fairly orangish red kind of color, but they have a nice harmony to them. I want the stroke to be fairly noticeable too, so I'm going to increase its width. For that, we have line width. I'm going to set it to 4, which means 4 pixels. So this is the style I want it to use. One thing I want to be careful of, though, as we're doing this, is that I do not want this to affect anything that happens later. So just like I said before, here we're actually changing the context. And I don't want it to accidentally also change, say, the background gradient or something like that. So I want to say context.save before I call these functions. You very often do that at the top of a function that's doing something. And then down here I'm going to say context.restore so that it gets back to where it was before. That's the idea. So this is going to draw our little heart right in the middle of the screen. Let's go take a look at that. Oh no! I forgot to call the function, draw heart. So let's get back up here. So we want to do it somewhere like right here. Let's do that. Ah, there we go. Well, there's a couple problems. We can see the line style didn't get set because it should not be black, it should be red. And it's spinning. I didn't intend for that. Let's see what we can do about both those things. Let's take a look down here at the heart. Stroke style, S-T-R-O-K-E, S-T-Y-L-E. Oh, I have 2 pound signs in there. That would do it, FF0000. Let's try that again. There we go. Now it's outlined in red. For the love of God, let's get it to stop spinning. I did not want it to spin. The background spins, not the heart. So what's causing the spinning? Well, it's this right here. When we rotate, that angle is the actual spinning. Well, this creates a bit of a conundrum. I actually do want it to rotate, but only the triangles and not the heart. Here's what we'll do. Let's take the rotation by angle and move it into the triangles function. So just before we draw the triangles, we'll say context.rotate. Here, just like we've been doing in the other functions, I want to make sure that that rotate doesn't happen to the heart. So I'm going to save the state before we apply the rotate and the fill style. I don't want either of those to come through. And then restore it just before I leave this function. And that'll get it to stop doing that, hopefully. So up here now, we still are translating to the center. We want that. Our heart was defined at the center of the screen. But we are not doing the rotation to the heart anymore, hopefully. Oh, we're not rotating at all anymore. What happened? I lost my rotation. Wow. All right, this was a bit of a tricky little problem. What happened here is we brought this in and said context.rotate by angle. What we needed to realize is that in the context of this function, draw triangle wedges, angle means something different. We have another variable here called angle, and that's the mistake. Now, how did I find this? I was looking through and asking myself, well, am I using the right word everywhere? Have I spelled it right? And here's a little trick. If you double-click on the word, it highlights it. And we have this extension installed called highlight. It actually will, when you highlight something, it shows you all the different places that occurs. It also shows it to you over in the map here. So I saw, okay, here's angle, and then I should also see it over here at rotate angle. Wait, what are these other ones? And I suddenly realized I had two things called angle. So that's how I sort of figured out what was going wrong. Now how do we fix this? Well, we've got to rename one of these two. I'm going to rename this one. We'll call them W and W2. So this is kind of like omega and omega 2, which is something you often use for angles. You could call them theta, you could call them A and B, honestly. These are not too important that these have a particular name. So now that gets rid of all the other things called angle. We just have now angle as one thing here. So there. A little bit of debugging to think about. When we refresh this, there we go. Now we're getting closer to the final example that we wanted here. So there's our heart, and then we've got our little spinning triangles around it, which might be driving you slightly insane, but yeah. Hopefully the colors are at least a little bit pleasing. Programmer art, right? Okay. Now the last thing I'd like to do, and this is where we get a little bit advanced. We've already gotten pretty advanced in this example, so don't worry if you haven't understood all of it. It's mostly just to really get your feet wet with all of this. The next thing I'd like to do is create a beating heart. I want to make the heart beat a little bit over time. And I happen to know that there's a function that we can use that has that sort of shape to it already. And so let me show you what this function looks like. What we're going to do is the graph of the square root of the sine of x. It's the square root of sine of x. And see what that looks like. Right here you can see at 0 it still equals 0, and then it goes up, boop, boop. So this is going to go up quickly, spend its time up there, and then come down quickly. So it's going to be like a pulse, a quick little pulse. And then during this time, it's nothing. Notice it's 0 right here. Why is that? Well, that's because technically it's undefined. What you have right here is the square root of a negative value. Now you probably know that means it's imaginary. You get this whole I thing. It's an interesting little result. You'll actually get another pulse right here in the imaginary plane that's different from the pulse in the real plane. Yeah, we're not going to worry about that. The nice thing is that it has this regular pulse stop, pulse stop, pulse stop, pulse stop. We just have to be careful that whenever the value is negative, we don't try and compute it. We just clamp it to 0 there so that we don't get that undefined y. We want to make sure that it is at least equal to 0. So this is what we're going to use for our heart pulse. And again, this is just something I happen to know already. It makes sort of a good pulse function. You're not expected that you would be able to figure this out without going and maybe looking up, seeing what other people have used for a heart pulse in the past. So the square root of the sine of a value. That value itself, because we're taking the sine of it, really should be an angle. So we could say, use this angle that we have that's already pulsing. How do we get it to apply to this heart and make the heart sort of beat? Well, if we use it, we can make it just make the heart grow a little bit. That's called scaling. So what we're going to do here first is compute the scale value. We're going to say var scale is going to equal 1.0. And that's essentially identity for scaling. When you say 1.0, you say don't make it any bigger or smaller. Just leave it equal. Scaling is actually a multiplication effect. And so the identity for multiplication is 1.0. Same for scale. The identity for scale is 1.0. Now what we're going to want to do is add on to this. We're going to say scale plus equals, and let's take the sine of our angle. Then we want to take the square root of that. Math.square root of the sine of our angle. And that'll essentially give us that function that we were looking at before of the pulses. But like I mentioned before, we've got to be careful. We always want to say if math.sine of angle is greater than or equal to 0. If it is 0, we don't want to do anything. We want to just leave the scale alone. So there we go. This will give us a little pulse. The scale value will grow a little bit when the angle is positive, and then it will just stay at 1 when it's, or stay at 1.0 when the angle is negative. And it should give us that kind of pulsing effect that we saw. The only thing that's left is to apply it. And just like we had translate and rotate, we can say context.scale and give it that value. Now you have to give it for both the x and the y. We want it to be even in the x and the y, so we say that. The other thing we want to make sure, anytime we're messing with translation, rotation, or scale, that we're saving and restoring the context before and after, and we are. All right, let's try that. Let's see what we get. Whoa, that's a big heartbeat. Ooh. Whoa. Okay, so it gets really big. This may be a little bit of an intense effect, intenser maybe than we want. So let's try and reduce the size of the overall effect a little bit, because this is going to double in size, because it's going to go all the way up to 1.0 and or 2.0 and then back down to 1 again. So let's reduce that a little bit. Let's say maybe we'll say 0.1 times that, and then, so that'll scale it down to be 1/10 of what it was before. And let's see what that gets us. That's a very subtle effect. It's also really slow, right? So let's see if we can make it be a little more punchy, have a little more speed to it. Also make it just a hair bigger. So angle is what we're using, and angle is already a value that's moving at a certain rate in order to control the spinning triangles, remember? We had that set up here. It starts at 0, it increases by 0.03 every single frame. We really can't change the rate that it is changing, but we can amplify it right here. We can just make it bigger, and so we'll say the sine of angle, I don't know, times 4, and that'll make it go by 4 times as fast without affecting the triangles. So let's see if we do that and what we get. Hey, that's pretty good. All right, I like it. We get a nice little big heart pulsing in the middle there. And so that's our animation. So what did we all put together here? We've got a whole bunch of little pieces that are coming together programmatically to make our little pulsing heart. First of all, we drew that gradient in the background. That was just sort of a little bit of icing on the cake. That's why we get this nice soft purple at the bottom. It's a nice effect, but certainly not necessary. It's the background that's behind everything else. Then we drew those radiating triangle wedges, the little pie wedges that go out, and we made sure they were big enough that we didn't see the end of them. So it just sort of looks like you're looking down this circular tunnel. And we drew 10 of those all the way around the circle. And note here that we are animating those. So now each time it goes through, we have an angle, and we're rotating those triangles all the way around right here so that they all rotate around a little bit, just by applying a rotation to the entire context. And we have to make sure we save and restore before that so that that rotation doesn't get applied to the heart. Lastly, we're drawing a heart, and we do this with our Bezier curves. Again, I just looked up these values from someone else who was smarter than me that figured them out. That's their connection right there. That makes a little heart shape. And we then went through and made it pulse by applying a scale to it that's equivalent to the square root of the sine function. And again, that was just one I already knew. This guy uses the same thing, is a pulsing function. It gives us the nice little pulse to it. And we just fudged it until we got it to the right size. This controlled the actual size of the scale, and this controlled the rate of the scale, where we multiply by another value. And this gives us our little pulsing heart animation. I will make sure this example code is posted for you to look through, so keep an eye out for that. If you had any problems with this or questions, please don't hesitate to ask. I don't necessarily expect that everyone in the class will understand all of this. This is getting fairly advanced. But I wanted to sort of push you a little bit further into something a little more interesting. When I talk about playing with the canvas, this is the kind of stuff I'm talking about. So have fun with this, and hopefully you've got more than enough here to tackle that little clock assignment. We're going to be going much deeper into JavaScript later in the class, so this was a real deep dive. What we're doing here is immersion learning. If it all felt a little bit disorienting, that's okay. Feel free to ask questions or just sort of let it soak in. It'll all make more sense as we keep doing it a little more formally in Unit 2.